Hi everyone. Yeah, this is Peter the Rock. I'm here. It's this is my first time of mentioning my name. I'm sorry about that. I'm here to introduce to you IP address. IP address. Sin. IP address. Okay. IP address is a unique identifier that is assigned to every systems connected to an IP network. It's a 32-bit IP long number, you know, in form of decimal number format. A group of four numbers separated by dots. Each group is called an octet. Now, let me talk about IP terminology. Terminology. Okay? Which bit? Okay. A bit is, you know, digit number. Is a digit number which is a digit number which could be zero and ones. Okay? Zero and ones. Okay? Another one is byte. Byte is an 8-bit. Okay? 8 bits, that is 8 of these numbers is 1 byte. Okay? Now, octet. Octet is, group of 8 bits. Okay? In form of 0.0, sorry, 0, 0, 0, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, dot 0, 1, 0, 1, 8 bits. That's, is an octet. Each group of this 8 bit is an octet. Okay? So network number is a number that router use to route, packet to destination network. Is a number that router has inside its routing table in form of this 172.168.10.0. This is a network number. Okay? That is it. Broadcast address is, 255.255.255.255. Okay? It's a 32-bit long number that is used to, send a packet to all networks. Okay? So that is it. These are IP terminologies. And let me still go ahead and, tell you how, why did I clean the IP address? IP address. Like this number 172.20. 30 dot what? Okay? Let's say dot 50. Okay? Let's say we want to convert this IP address into bits because IP is all about bits, which we need to write our place values 128, 64, 32, 16, 8, 4, 2, and 1. You can see that this group of 8 numbers, which represent each of these octets. I can see this is an octet, this is an octet. Okay? So let's say I want to represent, I want to, convert this number here. You can see 172 minus 128. Sorry, let me use my calculator. Okay. Okay. 172 172 minus 128. Okay, you can minus it, which means you put 1. Okay, which is remainder 44. Can 44 minus 64? No. Can 44 minus 32? Yes. Minus 32. Okay, which is 1 here. Remainder 12. Can 12 minus 16? No. Put 0. Can 12 minus 8? Yes. Minus 8. Remainder 4. Okay, here. Can 4 minus 4? Yes. Nothing is left. So this 172. 172. Okay. Now let's get to 20. Okay. Now, can 20 minus 64? No. Can this 128? No. Can it minus 64? No. Can it minus 32? No. Can it minus 16? Can 20 minus 16? Of course, yes. 20 minus 16 is left with 4. Okay. Can 4 minus 8? No. 4 minus 4? Yes. Nothing left. So 0, 0. Dot, which means this is 20. Okay. 30. Let's convert 30. Can 30 minus this? No. Can 30 minus 64? No. Can 30 minus 32? No. Can 30 minus 16? Of course, yes. 30 minus 1, 6, 14. 14 minus 8, minus 8, 6. 6 minus 4, 6 minus 4, 2. 2 minus 2, and 0. Okay, so here this is 30. Okay, let's use 50. Can 50 minus 128? No. Can it minus 64? No. Can it minus 32? Of course, 50 can minus 32. 50 minus 32, left with 18. 18 minus 16, 2. 2. Can 2 minus 4? No. 2 minus 2, 1. Nothing left here. Okay, you can see this IP address, okay, which is 50 here. You can see this IP address has been converted to bit. This is how IP address works. You can convert IP address into bit. When you say IP address is a 32-bit, you can see these are the bits. Okay, 8888 into 4, which is 32. Okay, so we can still go ahead and do something. Okay, let's convert these bits into hexadecimal number. These bits, let's convert them into hexadecimal number, which can also be MAC address, physical hardware addresses, media access control. If you check every media access control, they come in hexadecimal, which you need to use Nembo. You share this into 2, you must use this 8421 to work on this Nembo. Okay, so now each of the bits must be separated by 2. Okay, look at this. This is 8. Okay, which is this 8. 8 plus 0 is 8. 8 plus 4. Remember, this is 4 here. After 8 is 4. 8 plus 4 is 12. Okay, the other one is 0, which means we have 12. What is 12 in hexadecimal? 10 is A, okay, 11 is B, and 12 is C, which means 12 is C. And what of this? This is 8. This is 4, which is 12. 12 is what? A, B, C. No, 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 no. I'm wrong. Sorry. This is 8. This is 4. And this is 2. 8 plus 2 is 10. So this is supposed to be A. This is supposed to be A. Okay? So here is 8 and this is 4. Okay? This is 2, this is 1. 8 plus 4 is 12. 12 in hexadecimal is what? A is 10, 11 is B, 12 is C. So AC dot. Okay? You come here, separate this. You can see it. This is 1. Okay? 1 here. Okay? Because this is 8, 4, 2, 1. And here is 8. This is 4. Which means you put 1, 4 for 20. Okay, for this, you put dot, you come here, separate this. Okay? This is 1. 1 here. And this is 8, 12, and 2, which is 16. 16 is what? In hexadecimal. What is 16? Okay? 10 is A, 11 is B, 12 is C. Okay? 12 is C. 13 is D. 14 is E. 15 is F. Which means F what? 16 is what? Is 16. Okay? Which is D. What is 16 in hexadecimal? Wow. Because this is 8, 12. 8, 12. Oh, 13. It can't be 16. It's not possible. Look at 16 here. This is 8, 12, okay, and 2. 8, 12, and 2, which is 14. Okay? 14 is D. A is 10, B is 11, C is 12, D is 13, E, which is 1E. Sorry. Oh, I'm surprised. So you come here and divide this as well. Okay? This is 2 and 1, which is 3. This is what? Is this complete? This is not complete. This is not complete. Okay? So let's divide this 50. 50 minus 32. 50 minus 32. 50 cannot divide 28. 128. It cannot. It can do the 50 minus this. 18. Okay? 50 minus 30 is 20. 18. 18 can minus this. Left with 2. 2 cannot minus 8. 2 cannot minus 4. 2 can minus 2. And we're left with 0. So you come here and divide this. Okay? So that is it. Now, here is 8, 4, 2, 1, which is 3. Yeah, this is 3. Now, this is 8, 4, 2, and 0. That's 32. You see? This can be assigned to MAC address. This is a kind of MAC address, which means this address has been converted. This address here can be converted to this as well. Okay? That is how it works. So let's come to, classes of IP address. Class A The IP address designer says that in a class A network, you turn every bit off. All bits. First bit is off. Okay? 1, 2, 3, 4, 5, 6, 7, 8. Turn off, which is equals to 0. Okay? Now, you turn 1 again. You turn 1, the first one off, and turn them on again. Turn them on again. You get 2, 7 power 2. Okay? Which is 128. But they cannot write 128 because it's 127 plus 0, making 128, which means in every class A IP address, you get this from 0 to 127. Okay? Now, the network portion of class A is like this, while the host portion is 24 bit. Okay? 24 bit, which is this where you get your valid host IP addresses, which means 2 power 8, okay? No, 2 power 24, sorry, because 8 bits times 3, that is 24 minus 2, okay? Which will give you 16,777,000, 216 minus 2, which is equals to 16,777,214 valid host addresses. Very large address, class A. Okay, now I come to class B. Class B. So the internet designer says that one first bit need to be on and others are off. Okay, and when you come here again, you turn one and off this, come here and turn all this on, you get 128 to 191. Okay, so now the host portion of it is 16 bit. That's the network portion, while the host portion is also 16 bit. Okay, so you work from this host portion, which is 2 power 16 minus 2, which will give you 65,000, okay, 536 minus 2 gives you 65,534 valid host addresses. You can generate in every one class B IP address. Okay, this is class C. Class C says that 2 bits has to be what? On, and others are 0, 0, 0, 0. Okay, then you get 192 to 223. And the network portion is 255.255. This is dot, sorry, it's not hyphen, dot 255.0. Remember, this is where you generate. Okay, that is 2 power 8 minus 2. Remember, you generate, it has only one host bit. Okay, sorry, this power outage. Hope you last watching. So 2 power 8, which means is 2 equals to 256 minus 2. Then you get 254 valid host addresses in a class E, network address. So this is how IP addresses works. Okay, this is how it works. When you hear bit, and also let me tell you, the internet designers still went, the IP address designers still went ahead to separate some private IP addresses, which ranges in a class A private IP address, start from 1.0.0.0 to 10.255.255.255. Class B Class B ranges from 172.16.0.0 to 172.31.255.255. This is Class B 192.168.0.0 to 192.168.255.255. These are private IP addresses. This is why we have not run out of IP version 4. Because what I'm teaching you is IPv4. Okay? IP version 6 is beyond the scope of this course. Okay? So this is it. Private IP addresses. You need to be conversant with it because on a Cisco exam, they will, mix both private and public IP addresses for you to select, or depict the private IP addresses, okay, from public ones. You should be able to identify them, okay? So that is it. So if you find this video interesting, go ahead and share it and see you in the next topic. Thank you.